My name is Thiago Almeida. I'm a PM on the Azure Functions team. And very appropriately, this session is about Azure Functions. And the two main topics for the session is scalability and security for Azure Functions. So we're going to cover quite a lot around those two topics. And just a reminder, make sure that you fill out our sessions survey. I'm sure you've seen this plenty already since yesterday, and you see it throughout the rest of the session. So we really value your feedback and would love to hear how we can improve our sessions in the conference. So the main topics that I have here planned for us, and the table of contents here is going to do a brief intro, then go into what are some of the main characteristics of scaling. And then we're going to break it between scaling for HTTP triggers. And I'm sure you've heard throughout the whole conference about building MCP servers, so that HTTP is part of that as well. And then scaling for non-HTTP triggered functions as well, and the differences there between the hosting plans and the trigger types and everything in those. And then after that, we will switch over to the security part of the talk, where we're going to cover both some notes on identity-based security and how you can implement solutions with Azure Functions with some identity best practices in mind. And then also, beyond identity, we're moving on to just talk about networking-based security as well. And then finally, any questions that you have and a wrap-up. So that's the plan for the session today. Cool. So just a quick intro here for Azure Functions. I hope you are familiar with Azure Functions. This session doesn't explain to you what Azure Functions is, but in my mind, just as a quick summary, it is both a programming model where you use the triggers and bindings that we provide to you and the whole programming model of Azure Functions to build your solution. But also, beyond just that programming model, we have the hosting options on Azure. And I'm going to cover a little bit more about the different hosting plans that we have shortly. The goal that our team has is to make sure that Azure Functions is the most productive and highly scalable platform for you to build event-driven apps that developers trust. And the scalable and event-driven apps really match up with the first part of the session, where we're going to talk about scaling Azure Functions. And of course, the trust part is the security part of the talk as well. It kind of ties to that. So that's our team's take on what we want Azure Functions to be and what we strive to do every day and improve Azure Functions to be the most productive, highly scalable platform to build event-driven apps for developers to trust. So if we move on to what are the hosting options for Azure Functions, we have consumption plans. And more recently, we introduced in last December, it went GA, a consumption plan called Flex Consumption. And this plan is the true serverless plan that we have on Azure Functions together with consumption. And it was built from the ground up on a platform that is shared with container apps. And it was built to provide scalability and also virtual networking on a consumption plan. So by consumption, I mean serverless, where it can scale to zero. You pay only for the instances while they're active. So if the platform takes 10 minutes to scale in, you're not paying for those if there's no executions there. So you don't worry about paying for compute that you're not actually using, right? So that's what Flex Consumption is for, is if you need a solution that is serverless, you pay only for what you use, and that can scale fast and can also provide networking. So that's what we built Flex Consumption for, and we've seen a really huge adoption since we went GA in December. We've had both existing Azure Functions customers as well as big enterprise customers start adopting it now, especially because it has networking. That was a big one of the biggest feedback items that we had for the consumption plan, but also scaling, being able to handle higher throughput scaling and faster bursts of scale than we were able to before with the rest of the hosting plans. But then we also have 3 more hosting plan options. So that's basically part of the flexibility that you have here. One is the Elastic Premium plan. So the Elastic Premium plan, it still takes in the event-driven source in consideration when it scales. But you have more ownership of what goes inside each box or each plan. So you create a premium plan, you can put multiple function apps in it. And all those function apps together will decide, all the triggers inside those function apps will decide how that premium plan scales. So if you have a lot of function apps that you want to combine in the same instance and let those instances scale a little slower than flex consumption out and in, or if you have constant executions, you always, for example, you have a busy event hub source that is always executing, always having events and never really has that fluctuation in numbers, then the premium plan is a great destination for your apps there. Because if you look at it face value, flex consumption would cost a little more than premium plan if there's always active executions on it. But of course, if it's up and down, then flex consumption makes more sense. The other hosting plan that we have now is container apps. Basically, you have a container app environment, and Azure Functions is a type of app in container apps now. So if you already use container apps for other solutions, or if you want to own the lifecycle of the container yourself, the container image, take it through your SDLC there for containers, instead of letting us take care of the container image for you like we do in flex consumption, then container apps is a great destination. So if you are starting today with Azure Functions, I would either go to flex consumption or container apps as a good option for hosting. And then finally, app service plans. These are very, if you look at app service itself, it has a variety of different instance sizes from the small free tier and basic tiers all the way up to huge machines that you can use. And I would pick app service if you have already web apps that you're using and those instances might be underutilized and you need some event-driven solutions to be a part of that. Then you can co-locate them with the web apps. Or if you want to have specific control of the scaling manually, you want to say, this app, I just want to have 2 instances of the standard plan. I won't scale out, it won't scale in, and that's where it's going to stay. So you need manual scaling. That's another option. And the last thing I wanted to call out is that both container apps and flex consumption, they're only Linux-based OSs. So app service and the Elastic Premium plan are good for Windows. If you have a strong dependency on Windows, you use some specific Windows dependent solution, then Premium and app service or the consumption plan Windows are options there. Nowadays, more and more as we talk to customers, they are building solutions with .NET isolated that can run either on Windows or Linux, and sometimes it performs better on Linux. So that's why we went to flex consumption just with Linux for now. And we don't yet have any plans to change that. So that's just a quick overview of the different hosting plans that we are investing in for Azure Functions, and you can take your pick between which one makes more sense for your solutions. So moving on to some of the core characteristics of scaling, starting from a high level. Something that I kind of called out in the previous slide was that app service, premium plan, even flex consumption and container apps, there's this idea of a hosting plan. And that's where you specify when you create a new app service plan or a premium plan or a flex consumption plan, you're basically saying this is the amount of memory and CPU that each instance of my app will get. So that's where you have the hosting plan. In the Elastic Premium and app service plans, you can put multiple function apps inside of that plan. So they basically are sharing that whole virtual machine that is behind that instance for you and running inside the same context there. But flex consumption, given that it's the serverless scalable solution, we basically want you to forget about a hosting plan. It's just a function app, and it does have a plan around it, but the plan has only one function app. So with flex consumption, you can create as many as you like of those apps because they will scale to zero. And there's no sharing of the compute between multiple function apps per se. So moving into that hosting plan, when you look at the hosting plan here, you can have multiple function apps inside the hosting plan for the EP. And once you have that function app, when you write your code, so if you've written your solution, your function app in C#, you will probably have created one or more functions in it. And all those functions are deployed together to that function app. And there's a difference in how your solution will scale depending on what triggers those functions have inside your function app as well. And as you can see here, we have a function app at the top with a timer trigger and an HTTP trigger function, another function app with service bus and a storage blob trigger. And on the bottom one, we have a flex consumption app that has 3 functions as well, 2 HTTP and 1 timer. And they're all sharing that instance. But with flex consumption, we went a little bit further, and I'll call that out a little later, where we have a per function scaling as well, so that we can ensure the determinism of the scaling for flex consumption all the way down to the function itself. So I'll go into that a little bit more later. All right, so probably a little obvious, but I have to call out that you can also scale up. Vertical scale is what the slide is saying, where you have, say, an app service plan on the standard tier that has 1 core and 4 gigs of memory. You can change it up to have 16 cores and 256 gigs of memory. Or in flex consumption here, you have a 2 gig instance size. You go into the either through CI/CD or in your Azure portal, and you can change the instance size to be a larger size. So if we have a look at, let me just exit out here real quick. So if we have a look here on the portal, I have quite a few different function apps. Let me zoom in a little. So this is a flex consumption app of the 512 instance size. It's the smaller size that we offer now. And this, if you're coming from consumption and moving to flex consumption, this is a good instance size to start with, because from the pricing perspective, it'll be pretty similar. But then you can go into scale and concurrency and change that size, from 512 to 2 gigs or 4 gigs. So as your app instances get scaled out and in, each instance is using that amount of memory. And in flex consumption behind the scenes, we have a mapping of instance size to CPU as well. So the larger instance size, the more CPU cores you will get. All right. So just to cover where in the portal you would do it for flex consumption. But then, of course, more importantly, I think, is horizontal scale. The vertical scale is good if you have one execution at least, or that at any given time with concurrent executions, you will need more memory than that instance that you were in before provides. So this is still good. We've had customers, for example, that are doing parallel executions of model inferencing with different parameters for the same model to find out which combination of parameters is the best for that model, for their solution. And just one execution of that meant that they went beyond the 2 gig memory requirement. So they went with a 4 gig, but they can still use durable functions or make parallel HTTP requests with a concurrency of 1 and get the app to scale out to, I don't know, 50, 500 instances of the 4 gig size, run that inference for 2 minutes, and then they all respond to the caller, and then they decide which one is the best of the combinations there. So that's where vertical scaling becomes important. But another one is horizontal scale. So that means that as you get more events, more HTTP events, more messages into Service Bus, your app can scale out to have multiple instances. And this, I guess, horizontal scale is the crux of the first part of this session. And in this scenario here, for example, we have Event Hubs as the event source. We have a component in Azure Functions, which is called the Scale Controller, a platform component. And it is monitoring those event sources, or at least the instances are talking to Scale Controller saying this event source requires more instances, and then the Scale Controller will talk to the platform and scale out your app. And this decision is being made constantly every so few seconds or so that your app is kind of adapting, in flex consumption, adapting to the source of events, which is Event Hubs here. So that horizontal scale, getting more instances to process from your event source, is quite key. And diving in a little bit more on the horizontal scale here, we have 3 types of horizontal scale. The first 2 mostly apply to app service, but remember before when I said you can control the number of instances manually, you can literally go into the app service plan and tell it, this app now has 10 instances, and it'll scale out to those 10 instances, and you're paying for those 10 instances regardless of whether there's executions there or not. So if you are, or you can do it at a schedule. So if you always know that, Friday night, I need so many instances because there's a big influx of data coming in, and then Saturday morning, I can reduce that down to the minimum of 1. You can definitely do that with manual scaling or automatic scaling based on a schedule with app service plans. But for the consumption plans, flex consumption, and for the premium plan, the approach is the platform scales for you based on the event sources of the triggers or the functions that you have in your function app or function apps inside the same plan. So the automatic scaling based on event sources is what I'm going to cover a little bit more for the next few slides here. Making sense so far? All right. So one thing that I forgot to call out with container apps, if you're hosting your function app in container apps as apps there, or for your other container app type of apps, you can work with KDA, the Kubernetes scaler solution that is open sourced, and container apps has native support for it, to then be the one that decides how many replicas of your app would have in container apps out and in. There's a session this afternoon by Simon that will cover scalability for container apps specifically. So if you're interested in that part, definitely recommend going to Simon's session this afternoon. All right, so we talked about vertical scaling, being able to scale up the size of each instance, and then horizontal scaling, getting that size into multiple instances to all process from the event source. The next important topic here is concurrency. This is one decision that we made, in that we didn't want to make concurrency equals 1 for every instance. We think that it's better if you can control allowing each instance to process more than 1, but you can definitely set in flex consumption, you can set the HTTP concurrency to 1, and the app will just basically try to serve 1 instance for 1 HTTP, and it'll scale out to that number and keep processing those events. But even with the smaller instance size of 512 megabytes, we believe that for HTTP especially, or even for message processing, you can and should be able to handle more than 1 execution at a time, especially with C#, which can handle parallel processing and async quite well. So there is definitely a a best practice here to make sure that you have concurrency well set for your applications. And the way that it works is all of it comes with defaults. So if you have an HTTP trigger function app in C# on the 2 gig instance size, we default the concurrency to 16. The platform tries to then provide each instance of your app 16 executions, HTTP calls. So that target of executions per instance, it comes with defaults, but you can change it. Even you can change it straight on the Azure portal if you would like. You can just go to your function app here, the same place where I had instance memory. You can change, when you say use a system assigned number, that documentation there will tell you what the defaults are. But for C#, it's 2 gigs is 16, and the 4 gigs is 32, and the 512 is 4. So it's basically aligned to the size there. But you can definitely change this to say, hey, I want it to be 1. In my Flex Consumption app, if you get 10 HTTP calls, it'll scale out to 10 if it needs to. If the first one didn't process fast enough and there's still executions pending, it'll keep scaling out, right? So that's where you would change it for Flex Consumption in HTTP. And the platform also, or the SDKs that our function apps look at, they can tell the event source. So for HTTP, it's our Azure Functions front ends. Or the front ends that we share with App Service anyway, but the front ends know how many HTTP requests are coming in. If it's event hubs, it's the length of all the unprocessed events across all the partitions in event hubs. If it's a queue, then it's the number of messages in that queue on Azure queue or a storage queue or Service Bus queue. So we have the target executions per instance. We know the length for the event source. And that basically determines how many instances the platform should strive to get your app to, so that it goes as fast as possible to that number, processes all the events, and then once it's done, it can scale back in. There's one thing in Flex Consumption currently that is worthwhile knowing. The maximum instance count that you can set is 40. So there's some customers that they just want to limit it to, say, 1 processor at a time, and it can't scale out beyond that, or say 10 or a low number, because they need to protect the downstream systems, a database that it's writing to, or something that can't handle parallel executions. And currently, the minimum that you can set is 40. Unfortunately, we are working on fixing that. But it's just one thing to keep in mind, that for Flex Consumption here, the maximum instance count, if I try to set it to 39, it'll tell me, we need to enter between 40 and 1,000. But we're working on this. This is going to be addressed pretty soon, so that you can set it to a lower number if you want to. And then your app, no matter how many events are in the event source, it will only scale out to, say, if I had set it to 40, it'll only scale out to 40. All right. And this is just basically another visual of concurrency control, where if I get 10 events and concurrency is set to 1, the platform scales out to 10 instances, and each instance is given 1 execution. And then if the rate comes down to 5, concurrency equals 1, then the platform just scales into 5. And if you get 10 events with a concurrency set to 2, then you get 5 instances, each handling 2 executions at a time, and then and so on. Of course, the platform strives to make this happen. It's never exactly a specific number given to each, because there's how fast they are processing might change. So when you look at the graphs later, you can see that it's not 100% each instance handled the exact same amount of requests, but it's a close approximation there to make sure that that happens. All right. So, like I mentioned before, automatic scaling based on event sources is the key approach for Flex Consumption and the premium plan. with flex consumption scaling very fast out and in. And when you think about an event source, it can be anything that triggers your function app. So if you have looked at the list of trigger types that we have, you'll probably recognize a lot of these. An HTTP call comes in to your function to execute. I even call a timer trigger an event when the schedule happens for your cron job definition for your timer trigger function. That's an event. A message is put into a queue, file is put into blob storage, or your event hubs or Kafka gets a stream of events coming in, or even for databases, there's the change table and change trigger that you can do. A document is added to NoSQL, or a row is added to a SQL Server table, for example. All of those can be events that then trigger your function. All right. So let's dig into scaling for the HTTP triggers, which is a great topic. So the way it works for the consumption and elastic premium plan is it will, when there's an influx of HTTP calls, it will create a burst of 4 instances first, but then beyond 4 instances, those basically front ends that we have, these front ends here, they will be pinging the instances of your app to check if they're busy or not, how busy they are. And there's an admin endpoint there that it calls to check, if are you busy, if it returns 4 to 9, or if it doesn't even return, it knows that it's overwhelming that instance. And then it talks to the rest of the platform. We have another platform component called data row. This is the one that actually decides if it can give more instances to the app based on capacity and everything else on the region and everything else. So it will scale out that app if the front ends tell it to scale out. So that's how it currently happens in Elastic Premium. And if we look at flex consumption, some changes that we've made to make sure that it scales very fast for HTTP, and we spent a lot of time making sure that HTTP scalability was a big thing for flex consumption, where those front ends, now it knows that concurrency that was set for the app, so the default of 16 for the 2 gigs on a C# app, for example, knowing that target and knowing how many HTTP calls are coming in, instead of pinging the instances, it basically will tell the platform to say, hey, this app, based on this concurrency and number of HTTP calls, this app now needs 100 instances. Don't add just one at a time and let the instances be overwhelmed. Just add 100 instances, handle those HTTP requests, and then the platform will recall those instances over time. Right? So that's one of the platform changes that we made. Of course, behind the scenes here, you can see here that says Legion. There's a good blog post that calls out and goes into detail about this platform, but it's basically a custom-built platform that we created with the Container Apps team as partners to handle being able to burst scale. And there's quite a lot behind that, of course, but we create placeholder pools for all of the instance sizes and all the combinations of languages, and we can assign instances very quickly out and in for your app. But for you, you're only paying when those instances are active for your app. So that's the great thing about flex consumption. All right. So let's have a look at HTTP scalability for flex consumption. I have a pretty straightforward demo here just to show it off. So let's see. So I have this function app here. It's a very simple one that has an HTTP GET function there and a POST. And then I have test data here that passes in information to it. And I can basically kick off a load test against it. It's deployed to Azure already. And I'm using Plow, but you can use any load testing tool, I guess, that you like to try it out. And what I'm telling you to do is do about 100 concurrent users sending as many requests as possible for a duration of 60 seconds. And you can see here in the results that it's basically doing about 3,300 requests per second quite happily with those 60 users. And the majority of the calls are within 15 milliseconds here. So this is going from this machine through the Microsoft Wi-Fi here to the load balancer front ends to my function app that then sends a response back to that HTTP post call with that test data, right? And the way that it can scale this fast is, all those improvements that I called out for flex consumption before. So we can have a look while that's running. We can even go into my function app. Let me find the right one. It's this one. And have a look at App Insights for it and live metrics as a starting point here. So live metrics will basically show me how many instances. You can see now there's about 27 instances kind of the app that it's scaled out to processing events. And one thing that I like to do, because this here, sometimes it reports more instances that are actively processing your events. Sometimes the platform scales out and in, and the ones that are scaling, when you scale in, those are marked to be drained. But while they're draining, they're still emitting logs for App Insights to know about. So they're not actively, you're not paying for them, and they're not actively executing, but they're still reporting to App Insights. So a better view, I believe, is on the logs here. So let me just load a query that I have saved where we can, let's see. Okay, so this here should show us the number of requests that are happening every second. And it should match very closely what we're seeing from Plow here. So about 3,200 on the mean. And we can see that was about 3.332 here. So that's the average number of executions that our function just handled. You can see I have the timestamp just for the last 4 minutes, and it's already picking that up. Another good query is to count how many instances we're processing those requests. So cloud role instance here means the actual app. Each instance as the app scales out has its own ID. And this just counts how many instances we're processing. And you can see pretty evenly went to 27 instances here processing the events, which is what the platform determined is the right amount for that kind of steady stream of events coming in from Plow. And the last one that I wanted to show here that looks pretty cool, that's mostly the reason I wanted to show you it, is the distribution of calls per instance. So you can see each instance here was given a certain amount, like that count there, 120, 263. So each instance is handling more or less, but within a range of your calls, and then ultimately being able to handle as much as my load testing was sending to it. So that's a quick look at scalability for flex consumption with the HTTP trigger. All right. So scaling for non-HTTP triggers. Now that's the next topic, and I really like this topic as well. So if we have a look at a few different scaling sources, I hope this slide is not too jarring. I thought about breaking it into one slide per trigger, but I think we can cover it here. Where if you have a timer trigger function app, only one instance can run on that schedule, right? You don't want multiple instances running at the same schedule and then executing your function twice. And the way that we do this, if you've seen your function app, it always requires a storage account, and you have that Azure Web Job Storage connection string that connects to that storage account. It's for things like this that it gets used. It creates a blob there, and it puts a lock on that blob so that no more than one instance will execute your HTTP timer triggered. Even if you're on the premium plan where other functions and other function apps are making the app scale and also have the timer trigger function in it, they won't execute if there's already a lock on that. For storage queue, what we look at is the depth of the queue. One caveat here for the storage queue is that if you set the invisibility timeout or visibility timeout on the messages, there's nothing in the storage queue SDK that tells you whether they're active or they're invisible. So the platform looks at both visible and invisible. Basically, the SDK, it's a little old, so it just returns the total number of messages in that queue, which for the majority of times is fine. But if you are depending on visibility timeout, I would probably move to service bus queues instead of storage queue, because that will give you the number of active instances and then scale your app to the right number. And speaking of service bus, of course, it can scale based on the queue depth as well. Or if you have a service bus topic with multiple subscriptions, your trigger is on that subscription. So you can have multiple apps, one to each subscription of your service bus topic. So it looks at the queue depth of that subscription. And you can change the defaults for your storage queue and service bus in host.json. There's definitely, it's well documented there how you can change it if you want to, but it takes the defaults based on the defaults from the SDK. So for example, 16 messages per instance, or it's all based on the size of number of messages that the SDK gives you, but you can definitely tweak those. And we've had customers, excuse me, that had to scale out event hubs quite considerably, and they played with those values to be able to handle quite a lot of events. So looking at event hubs, Kafka and Cosmos, they're all kind of partitioned solutions. So if you think about event hubs, when you create the hub, you choose the number of partitions. And of course, the higher the tier of event hubs, the more partitions you're going to get. And what Function App does is it looks at the number of events across all those partitions, but it won't scale out beyond that number of partitions. Because when a processor in event hubs, normally, if you build it from scratch with the SDK, there is one processor that gets attached to that partition, and it owns that partition. And I have a couple of slides to talk a bit more about event hubs here, but the key is to know that it scales based on the number of total events across all partitions, but then the cap will be the number of partitions. And blob storage is an interesting one. We have two types of blob storage source. We have a kind of an older legacy one that is called the logs and scans, and it basically looks at the logs from your storage account to check if any new blobs were put in there. And it has, so that it doesn't check your storage account often, it starts to back out when there's no new blobs. So you can end up with a time when a blob is put into blob storage, and it takes 8 minutes, 10 minutes for that blob to be processed. So that's why we introduced the event grid as a source. It adds a little bit more complexity into your solution because you need an event grid subscription on the blob as a system topic. But it basically instantly will tell your function that a blob was put in there, regardless of when was the last time that you actually executed the function. So that's why specifically for Flask consumption, with the event grid source is the only one that we support. We don't support the logs and scan anymore in Flask consumption. Because of that fast scaling that we implemented into Flask, we thought this would be the best approach. And then with Azure SQL, it's unprocessed change count that we look at Azure SQL, kind of like Cosmos as well. So any new blob, any new documents, there's a change feed that happens there. And we just implemented the same for Azure SQL for the number of unprocessed change count numbers from the change table. And that's how the platform determines how to scale. So if we, just as a quick look here, I wasn't planning to show this one, but if you look at an event blob triggered function here, let me see this one with no VNet. So I have my function app. Let me zoom in a little. I have my function app. I have my storage account that is triggering from, but then I have an event grid topic. And that topic, it looks at that storage account as the source for the subscription here. And then it sends it to a specific destination on my blob triggered function app. And I haven't used this for a few days actually. So if we have a look at the storage browser here, blob containers, I have a processed and unprocessed PDF here. So I'll delete that guy from my storage account and from unprocessed as well, might as well. Okay. So let's upload a few PDF files to it. Open that, upload it. So that's uploaded there. And if we go to processed, those get processed straight away, right? There's no like 8 minutes waiting for it to happen. And that's because Event Grid woke up my function app. It's a flash consumption app, so it very quickly picked up those and processed them. Question?
The metrics phrase, right? Like CPU or
Nothing?
seems more natural. Like, why is I'm going to use ERPs loans?
Right. So the question is the metrics-based scaling seems more natural than this. The thing that we heard from customers is just the determinism of it didn't work for them. We are working on ways for flex consumption where you could also add some thresholds that are not just event sources to then have that as an option. We're going to start with a threshold based on concurrency, but nothing stops us from then adding thresholds based on metrics. So that's a good question and good feedback. Because in flex consumption you pay only for when you're executing, and it scales out to handle as fast as possible, like you saw here. The concurrency-based approach was the best one that we found for it to scale fast, right? And handle those events as fast as possible. When you look at metrics, the scaling determinism kind of disappears a little because it has to reach that threshold and then add. But we are working on, or we're considering that as an option as well, where you can do both either. So either metrics or event sources. Yeah.
How would you know if you care about metrics-based scaling, how would you set your these numbers, like
concurrency?
You set goals or work for them?
Right. Yeah. So the question was, how would you know what to set the concurrency for if you care, about the metric itself? And we did introduce one thing to look at is in the metrics for your function app. So let me go back to the function app here. And if we look at metrics, we introduced a few metrics here that help, which is the average memory working set and the CPU percentage. So you can kind of keep an eye on those to see if it's being underutilized, overutilized, and you can always increase the concurrency to make sure that it's more utilized than what it is now. So that's one approach to look at. But definitely very valid feedback that the metrics-based scaling also makes sense, even if it's for flex consumption when we want it to scale fast, right? Cool, thank you. All right. So for event hubs, just to do a little deeper dive here, it scales based on number of unprocessed events distributed across all the partitions, like I mentioned before. But you usually start with one instance of the app processing from all those partitions. So that instance creates leases or processors from each one of those partitions. But then eventually the platform decides that, this app can't handle this anymore. I need to scale out. And it will then add instances or remove instances based on the number of active events still on those partitions, right? And that's when the platform scales out, and those two instances kind of balance out between them, reading from those partitions. And this keeps happening over and over again until you end up with one instance of the app per partition, processing as fast as possible from that partition. And then beyond that, you either have to increase the number of partitions of your event hub, or you need to scale up your app so that it processes faster from the same partition. So those are two approaches. And you can further fine-tune the throughput, and this is something I would always recommend, is reading as a batch from event hubs. We've had a customer recently that they were trying to reach a specific number of throughput, and they couldn't get beyond 5,000 events per second. But as soon as they updated their code to read a batch of events at a time per function execution, that throughput went, off the hook, and they easily went over I think it was 12,000, 16,000 that they wanted to achieve. So with event hubs, I would always recommend considering reading events as a batch. If you want to process messages one at a time, then that might be a better idea for service bus queue, for example. All right. So one further concept is how, when it scales, your app in the consumption and premium plan, it will have all of those functions processing from the source. So here we have multiple event hub functions. They might be looking at different event hubs, for example, but all of those event hub triggered functions, they are voting and they are scaling together. So all the instances will have that instance, and then once all of the instances of your app will have that same function executing, or those functions, and they are fighting for CPU and memory in the instance. And also they're voting to scale out differently, right? You might have a service bus function here that wants to scale to 20 instances to handle all the messages in the service bus. And you might have an HTTP trigger function that just gets one executing at a time very slowly and can only scale up to one. So that's how it works in Elastic Premium. And for flash consumption, what we did is we created this notion of a per function scaling. All of your HTTP triggered functions in flash consumption will still scale together and get given HTTP calls for all those functions, but and blob and durable functions. But anything else, it kind of scales on its own for your function app. So you don't have to change your programming model. You can still keep all those functions inside the same function app in your code, say an HTTP triggered, an event hub, and a service bus one. But behind the scenes, the platform is scaling them into their own instances so that the scaling is deterministic based on the concurrency, even if you have multiple in the same app. The only thing to keep in mind here is, of course, the max instance count. It's still the max instance count currently for the app. We're looking at introducing something that you can control the max instance count per function group as well, so that you can say, only scale my service bus 1 to 1 and let the event hubs 1 go nuts and scale to 1,000. All right. So I'll do this demo together with the identity-based one. So we'll go into that now. So we have moving on to security now for your function apps, right? And the first thing is just starting with basics. This should be not just for Azure Functions, but everything on Azure. The first thing is to try to go passwordless. So favoring identity-based connections, like using Enter ID, Managed Identity, OpenID Connect, and all of those. And when you do, as you switch over to using identity as much as possible, then turn off local auth key access and other connection string-based access to your event sources for your function app. And then make sure that you are always deleting service principals and tokens and secrets from disk, environment variables everywhere that if you're not using them anymore. And then if you must use passwords, for example, your function app is connecting to some external system that doesn't have any notion of Azure Managed Identity or even auth of any kind other than a connection string, then you can still do that, but make sure that you save that connection or information in Key Vault so that at least it's secured by Key Vault, and your function app uses identity to get it from Key Vault instead of you just saving the password yourself. Cool, so that's the basics. And for identity management itself, there's a couple of types of identities that you can give to your function app. The first one is system-assigned identity. This is super easy to configure. You go into the identity tab of your function app and just say on or off. And when you turn it on, the system creates an identity for your function app to use to connect. And it's the quickest one. Usually, we would recommend for production. Let me turn off that. Okay. Usually, for production, I would recommend using a user-assigned identity. That's mostly because then you can reuse that identity if you need to delete your function app for some reason and recreate it. If you delete your function app and recreate it, the system-assigned identity goes away with it. And you have to turn it back on. You have to give it access again to all of those event sources and destinations. So with a user assigned, it's durable. It's its own resource on Azure that you can reuse, of course. And you can also share that identity if you want, but I would probably just create one per function app if possible. By default, when you use managed identity with function apps in the app service, in the app settings, it will default to try to use the system-assigned identity. But when you add the app settings for client ID and the URI name for your credential and URI, then that's where it will try to use that user identity as the source for it. So you can have a look here. Hopefully that's visible. But I have my Azure Web Job Storage _ blob service URI. So that's URI here. Then client ID, which is that. And that's basically the client ID of my user assigned identity. And then a third one with a static value of managed identity. When you have those three, you can also do _ account name for storage, but this is a little bit more proper. This tells the platform or your function app that I assigned that user assigned identity, and that's what I'm going to use to talk to storage. With system assigned, you don't need the client ID or credential. You just need the account name or the URI. Cool. And then beyond that, once you have that identity assigned with your app, you need to then decide which roles to grant, and then grant those roles least access for accessing your other Azure services, for example. There's a few places in Azure functions that you would use identity for. One is deployment package storage location, especially for flex consumption. You can either use a connection string or a system assigned or user assigned identity, and you can tell it that it's in a different blob storage account than your Azure Web Job Storage. So if you want to have different teams that do different parts of it, and one does the deployment and the other manages the running of your function app, you can separate those two. So you can use that identity to access the deployment storage. For the host storage, the one that I talked about before, that the function app needs just for its inner functioning, you can also use identity there, which is what that image is using there. And then finally, anywhere where you have an Azure trigger, an input binding, output binding, or even your own SDKs, if you're instantiating SDKs from your code, you can use identity as well, the identity of the app. Question?
Like for why Serverless is not recommended for project. Was like it's a user like Samuel have not calculated for fraud. Why is that?
No, it's more because of the durability of it. If that function app gets deleted and recreated, you will lose the system assigned, and it gets when you re-enable system assigned, it will create a new principal ID for it, and then you have to go into each one of the data or the sources destinations and give it access again. It's not that it's more or less secure. It's just that reusability of the user assigned is better. So you don't lose all that configuration that you made already to the access to the right things, just in case the system assigned identity gets removed together with the function app.
So the user assigned one does not have expiries?
No, it's a separate resource in your function app. So if we have a quick look here, let me see. Well, any of these should have it. But if I go to identity, you can see here the system assigned is turned off. I can turn it on, and it'll give me an ID. But if I deleted this function, redeployed it, it would get a new system assigned identity. But with user assigned, it's actually a separate resource that I'm just attaching to my function app and saying this function app has this user and it will use it when it connects to things. So, but it's a completely separate resource in the resource group. Or we can look at the resource group here. You can see it here, a managed identity, which is separate. So that's the key difference there is between those two. All right. And then, of course, once you have that identity, either system assigned or user assigned, you now need to basically give role-based access to your sources and destinations. So you can have a look here. All of those roles that we have, monitoring, metrics, publisher. I don't know if you know, but now App Insights also supports managed identity. So you can give your function app access to App Insights, then turn off local auth. And then storage here, data contributor, data owner, data contributor for the queue table. And for blob storage, data owner is still required for a few things. It needs to create containers and a few things that the data contributor can't. So you kind of need that. But we have some good documentation as to which permissions to give to each one of the trigger types and bindings like service bus, event hubs, and etc. Cool. And then the last thing here is inbound auth for HTTP and MCP. If you're building MCP servers using function apps or any HTTP API that you're building with function apps, if you want to secure that with auth as well, then API Management Serverless Gateway is a good and easy way to add intra, OAuth, OpenID Connect to anything, but including function apps. Or we have, as part of Azure Web Apps and Function Apps, we have EasyAuth that then allows you to quite easily expose Azure intra authentication or OAuth or IDC as well. And then you can also access and use the bearer token for outbound calls on behalf of that user. And we have here a sample in case you want to check it out for MCP and API management with auth on top of your MCP server. And the MCP server is hosted on function apps as well. All right, so let's have a quick look here. Accessing resources with identity with Service Bus. For this one, let me just switch quickly. Just a sec. Bear with me. Okay. So I have here an app that is a Python app. It didn't have to be, but in my local settings, what I configured for my Service Bus connection is just the Service Bus connection fully qualified namespace. There's no Service Bus access key or connection string in my local solution here. And I can run it. And because my identity, I'm logged into the AZ CLI with my corp identity that is part of the tenant of Azure Functions, it will run it as me. And then if we go into, while that starts, if we go into our Service Bus solution that we saw earlier, let me refresh Service Bus here. And then, of course, my Service Bus app has access control. I have access to the Service Bus as well as an identity. So for this resource, for this Service Bus namespace, myself and that ID of the function app have access to it to be able to send and receive and etc. So when my function app runs locally, it's running in the context of my identity, and that's why I can still run this locally against a Azure Service Bus, but not put any secrets in my local file as well. It just uses my identity for it. And then, of course, if my function app is processing from there, it also will run as the identity of the function app. So I can easily, just delete these two, and I won't be able to then connect locally to my Service Bus. One thing I said I was going to do before regarding concurrency for Service Bus, maybe we can do that now. But I can go into my Service Bus queue here, into Service Bus Explorer, and peek from start. There's 0 messages in there. Let me see. I might need to add myself to the network. Oh, yeah, my IP address changed. So basically, from a networking perspective, I also have to allow my laptop to connect to it. Okay, that's updated. Now I should be able to send messages to my queue. All right. So in Service Bus Explorer, peek from start, it should show that it's empty. So let's send a few messages. I'll say here, via slides, and I'll repeat send about 50 of them. And one thing to notice here in my code is in host.json, I updated the max concurrent calls for Service Bus to 1. So that basically tells the platform that I want each instance to handle 1 message at a time. Kind of like what I was saying before with the parallel processing of events. For example, you can drop 50 messages into the queue. The platform is scaled to 50. Each instance will be given one message to process at the same time. So now, peek from start, it's got the 50 messages there. And the reason they haven't disappeared yet is because in my code, I have a time, just a sleep there for 30 seconds. So it's waiting for 30 seconds to process those messages, just to show that the app scaled to 50. And they are all waiting for those 30 seconds before they finish processing my message. And now they're all gone. So it basically went out from 0 to 50, processed them, and now it's back to 0 again, which is the concurrency control, but for a non-HTTP source. That's all I wanted to show here. And then, of course, we talked about identity. And the difference that you will see when we look at my function app here is Service Bus. My function app, the deployed one, is that I have those extra environment variables configured for Service Bus. So locally, I only had the fully qualified namespace, but here I also have the client ID and then the credentials set to manage the identity. So that's how the platform knows that locally it's running as me. When it's deployed, it's running as the client that this identity is attached to. Cool. So we're in the final stretch here. Networking-based security. So this is where you want your function app to be restricted to the network inbound. That's one part of it. So you want to restrict what can access your HTTP endpoints on your function app to be only through a network or only from a specific list of IP addresses. So the flex consumption plan, the premium plan, and app service plan all have all of these options. You can specify IP ranges. You can join your function app as a service endpoint to a VNet through a subnet. You can private endpoint it with private link. And then if you want to give access to your function app, you can use App Gateway or Azure Front Door to protect and then manage the inbound traffic flow, but then route those calls through the network into your function app. So that's for inbound. And then for outbound restrictions, when your function needs to reach something that is inside the VNet, that's where you use virtual network integration. So you can protect the inbound, and now for the outbound, your function app calling things, you use VNet integration. And then if you want to further allow your app to go through the VNet and out, you can use Net Gateway as well as a solution there. So I'm sure if you know networking or if you've used networking on Azure, these all make sense to you. But this is with VNet integration is how you make sure that your function app can make calls to the inside of your network and run from the inside of the network. So last quick demo here before we wrap up. Just wanted to show the networking aspect. You saw me do it already a little bit by showing in the service bus how it's network secured. And here it has a private endpoint connection configured. So either you come through the network that this is associated with, or you're in this firewall list here of IP addresses. So this is my home network, some of the Microsoft ones here that I added today. But I could pretty easily, just leave this as disabled, and my function app would still work against the service bus. And that is because, I'll wait for that to finish. All right. And that's because my function app in the networking tab here, we will see that it has VNet integration configured right there. So it's to the same network, just a different subnet. You can VNet integrate multiple flex consumption apps into the same subnet, but that subnet that flex consumption uses can't be used by other services. So you can't private endpoint service bus and VNet integrate your function app into the same one because the delegation is already owned for that subnet. So you just need a separate subnet. Another cool thing about flex consumption is that each instance of the app doesn't use one IP address from your subnet. They share IP address there. So even for an app that will scale to 1,000, you can still have a somewhat small subnet size around 40 IP addresses or so to handle all of those instances that are going through the same gateway out to make calls there, which is pretty cool. It's a little different from the premium plan and app service plan, where as the app scales, each instance takes one whole IP address from your subnet. Cool. So that's a super quick overview of networking and how you would configure that. And I hope that makes sense, protecting the inbound, protecting the outbound, to make sure that your whole function app is protected through the VNet. Of course, when you have only triggers that are triggering from, say, Service Bus, Event Hubs databases, that's still the function app going outbound to those services, picking up events. So that's why you need VNet integration for my app to be able to read from Service Bus through that private endpoint that Service Bus has. But for HTTP is where you would enable the private endpoint. Cool. So now we only have 5 minutes here. I'll just do a quick wrap up. I have a couple of case studies just to call out, and then it can cover any extra questions that you have out here. The first one is GitHub. I've shown this before a few times already, so I'm sorry if this is a repeat to you, but they basically have this, they collect about 700 terabytes of data that they use heavily to detect malicious behavior against their infrastructure and for troubleshooting. And the implementation that they had was kind of limiting the growth of their solution. So they partnered up with us with flex consumption and then looking at a big Event Hubs source for all that telemetry, and having flex consumption scale out to close to 1,000. I think they hovered over when they were at that peak of processing 1.6 million messages or events per second. They were close to 1,000 instances of the 2 gig instance size there. And they were all looking at one partition. So it was a big Event Hubs that they had with 900 partitions or 1,000 partitions. But they're now moving on to multiple Event Hubs and then multiple function apps looking at each of those Event Hubs to kind of split it out between regions and etc. But just to call out here, a massive number of events being handled by GitHub with flex consumption as an event source with Event Hubs. And the other one that is cool here, just to call out, the Indiana Pacers. If you haven't seen this case study, it's a pretty cool one. They are using Azure AI Foundry and Azure Functions during their live events to generate captioning for the game. So for the hard of hearing or non-English speaking fans. So it both will stream through AI does the translation, function apps then pushes it to SignalR that distributes it to the Jumbotron, to the Pacers app, and also will push the translation as well of what is being said. So they wanted everyone that's in there, non-English speaking, hard of hearing, deaf, to be able to enjoy the game and hear what the announcers are saying, because they're very lively and excited about the game. So this is a pretty cool solution that I would check out if you want to learn more. There's a cool video here that shows what they implemented as well. And just to show, boom, Azure Functions right there in the middle of it. And that's all event-driven from the custom speech and text models that they trained for OpenAI through functions, then delivering it to the variety of destinations of where that captioning should go. And a few resources here. First, I wanted to call out this afternoon, if you're, I'm sure you've heard of and are looking into how you can embed AI into your solutions. And we're doing quite a lot of work with Azure Functions and AI. So I would recommend that you go and check out Eamon's session today at 1:30 p.m. He's going to talk about serverless functions and AI. So in building MCP servers there, the triggers and binders that we have to help you there if you want to, and everything else, connecting to AI from Azure Functions. So it should be a pretty cool session. And you can use what you learned today to both allow your functions with AI to scale and be secured with identity and networking. And then there's a few more links here. Does the just documentation of scaling and hosting, the quick starts that we have created. All of the latest quick starts that we built use flex consumption, AZD, Bicep, and they are using user identity and VNet. You can optionally not use the VNet, so it doesn't create the VNet, but if you enable it, then it puts everything inside the VNet as well. And a few more samples there. And then if all else fails, just hit me up on LinkedIn or on Twitter or X at NZTHIAGO. With that, I think we're right at time. Stay connected, use the VS Live Hub, and please provide session feedback. I'd love to hear more from you, what other topics you want, what I missed here, and what you liked and all of that. Cool. So with that, thank you very much for being here with me. Share the recording with your coworkers and hit me up if you have any follow-up questions. I'll be here just transitioning off. So if you have any questions, just come up and I'm happy to answer. Thank you.